Hi guys, this is the day 5 video, which means this is the last video of this week, and this is also last video before we review on Sunday, and you have a quiz over section 1 through 3 of this chapter, and the quiz will be open from Sunday through Monday. So if you already feel confident in your skills, then you can go ahead and take the quiz. But if you're not, you can wait for the review video and you can take the quiz on Monday or later on Sunday. I'll post the review sheet over the weekend so that you can look ahead. Today we are going to find some of geometric series, so partial sum, but also some of infinite geometric series. I see there is a typo here. So let's go to the formula for the partial sum. So partial sum, there are some elements that you need to know. A1 is the first term in the series, and R is the common ratio. Remember, the geometric series is different from arithmetic, meaning that to find the next term, you have to multiply by a same number instead of adding. And N means which term you're adding up to. So let's use that formula to find our partial sum for that first example. The question asks, find the sum of the first 11 terms. So we are looking for S of 11 of the geometric series of this sequence. So first thing we need to do, since A1 is given, A1 is 7, we still need to find out what R is. So to find R, we do negative 24.5 divided by 7, which will give us R. So I do that quickly on a calculator, and that's a negative 3.5. So then we have all the elements we need to plug it into the formula. So S of 11 is 7 times 1 minus negative 3.5 to the 11th power over 1 minus, negative 3.5. Okay, so on the bottom, you can change to plus because double negative, but on the top, you can't quite do that because this one has an exponent. So you need to follow the order of operation. So I'm just going to type all of them into my calculator. Just be careful when you're putting everything at once because you don't want to make a mistake by not using the parentheses appropriately. So the answer I'm getting is very big. You might want to check my calculation because I don't know if this is actually correct. It seems very, very big. Okay, so that's what I got. So I actually just did 1 minus negative 3.5 to the power of 11 first, and then I did 1 minus negative 3.5, and then I multiplied that to 7. So that's how I got that answer. So I just did it. I didn't type all in at the same time because I was afraid I would make a mistake. All right, let's look at this example. Find the sum of the first n terms of geometric series with the first term negative 8. So A1 is negative 8. And the nth term, we don't know how many there are. And then there is R equal negative 4. So this one, we can't automatically use the formula for the series. So we need to go back to yesterday's lesson where we used the formula to find out an. So it was A1 times R n minus 1. So let's plug in all the numbers that we know. It's 131072 is equal to negative 8 times negative 4 n minus 1 power. So let's isolate n by dividing each side by negative 8 first. Okay, and then I get negative 16384 is equal to negative 4 n minus 1 power. We have to use log here to bring the power down because I don't know how many times you have to multiply by n. But we have a problem because they're both negative. And do you remember how in log expression, you can't have negative? So I'm going to change it to positive by multiplying. No, actually, this is what I'm going to do. This -1, if you remember from yesterday's lesson, it also meant -4 to the n power over -4. Right? Because the negative, you subtract the power whenever you're dividing it. So then I can multiply both sides by -4. So I'm going to do that. Okay, I'm going to multiply both by -4, -4. So then it becomes positive 65536. Okay, how does this help? I don't know. I guess all I can say is that n has to be positive because my base is negative. So I'm just going to ignore the fact that it's a -4, okay? Because I can't use log with the base -4. It doesn't work like that. So I'm going to just ln both sides. And I'm going to just assume that this is 4. The only reason I'm doing that is because ln cannot have negative number inside. So I'm going to do ln 65536 divided by ln 4. And n is 8. And that makes sense, right? Because we need to have a positive n, even n to make the negative go away. That was tricky. So n is 8. So we have all the things that we need to put it in the series formula, which went like this. S of n is a1, 1 minus r to the n power, and 1 minus r. So let's plug it in. S of 8 is -8 times 1 minus -4 to the 8th power, 1 minus -4. Okay, so let me do that on a calculator. I feel like you guys are gonna be asking me lots of questions about what just happened. About how can you just make it not negative. It's just I'm working around the rules, okay? So I don't have to break the rule. Alright, so the answer is that big number. Just watch this video again if that was really confusing, okay? Let's see. Let's look at the sigma notation. It has been appearing since we started this chapter. What's important here is to know which one is your R. So R is this guy, right? Because AN is A1 times R and minus 1. So we know that R is -2. So basically, this one is asking S of 8. And we do know A1 because A1 is when you when you plug it in, this little one to here. And 1 minus 1 is 0, so it's 2. How else also do I know? Because this 2 corresponds with this A1. So 2 times 1 minus R is -2 to n power, which is 8, over 1 minus R. So it's, I don't like the fact that there's just so much calculator. Times 2 divided by 3. So I get -170 as an answer. But again, since it's a small number sigma notation, you can technically plug in 1 add, 2 add, all the way to 8. You could do that. It will just take a long time. Okay? So I don't recommend it. let's try this one. So I changed the problem so that you can see this kind of problem too. So here, the problem is that it's not starting with 1, it starts with 3, right? So again, just like the long method, you could technically plug in m equal 3 all the way to m equal 8 and add them together, okay? Another way we are going to look at it is using similar type of manipulation that we use for arithmetic series. So we need to know A1, which is technically A3, right? So A1 here acts like when m is equal to 3. That's basically when A1 is. So we plug it in. 32 times 1 over 2, 3 minus 1. So it's 32 divided by 4. 32 divided by 4. Because it would be 2, and then 1 over 2 squared will be 8. So 8. And then R is this number here, right? And technically, for the formula, I need A1, which is 8, 1 minus R to the n power. But how many terms is in between 3 and 8? It's n is 8 minus 3 plus 1, right? So there are 6 terms. 3, 4, 5, 6, 7, 8, right? And then you plug this into the calculator. Then it's 15.75. So you can solve it this way, just like the arithmetic series. So yeah, that's the summation. What's interesting about the geometric series is that unlike arithmetic, there is a time that the infinite geometric series converges, meaning that there is a limit. And it only works when absolute value of R is less than 1, Okay, meaning that your ratio has to be smaller than 1. And it follows this formula. So let's check out the first example. Let's figure out what my R is. It's -1/2, isn't it? And then -1/2 is less than 1 in the ratio, so absolute value of -1/2 is less than 1. So then we can plug it into our formula. S of infinity, so infinite series of this is A1, which is 10, over 1 minus -1/2. Isn't that kind of cool that even though it goes forever, it converges? And this is 6.6 repeating. Okay? Yeah, something doesn't seem right, does it? Oh, no, it does, because there is a negative. It's going negative. And then let's go this problem. So first, we need to check. Even though there's ... you don't just get excited and plug it in. You need to check what is my R. And this one is 0.75. So we plug it into S of infinity, which was A1 over 1 minus 15 over 20, which is 0.75. Which is 0.25. So it's 80. Okay. This one, just like I said, you need to realize which one is the ratio, and ratio is 0.9, and which is less than 1, so the infinite series formula will work. So 0.4 will be my first term, 1 minus 0.9, so it becomes 4. Last one. This one, unfortunately, so this one, what you're not seeing is that there is 1 in front of it, right? So the first term is 1. But the R is -4. The absolute value of -4 is not less than 1. So therefore, the sum does not exist. And that's it for today. and I will see